And remember what I told you.
Yeah, don't make eye contact. He takes it as a personal challenge.
Hello? Pat?
Yes.
Can I get a,
He'll take a Raspberry Pi 3.
No pie for you.
Told you. Hey, but I did hear this new deli. I can go pick up the sandwiches.
No.
Don't be held hostage by the board. Go to digikey.com to find thousands of boards in stock, all ready for immediate shipment.
Welcome to this, the first Make Live of 2019. We're a little bit of a late start this year. I understand, it sounds like I'm clipping a little bit. Let me take care of that. And let me start off by saying thank you for bearing with us. We've had a couple of issues. Like I said, it's the first episode of the year. But we're ready to get going, and we're ready to get going on an exciting year of Make Live. If you're new to this show, if you haven't seen it before, this is where we build projects straight out of the pages of Make Magazine. And but there's been a little bit of a change this year. Apparently, let's be honest, I'm not the best project builder in the world. I try, I fail a lot. And so there was a request to bring in some experts this year. And that's exactly what we've done. Joining me on the other side of this stream is Brandon from Particle. Brandon, say hello.
Hey, Tyler. Thanks for having me on.
You're more than welcome. And why don't you tell us what we're going to be building today?
Absolutely. So late last year, for the last several months, I've been working on a set of RC cars. But basically controlling those RC cars via their individual remote controls. I created a mesh network of RC cars using Particle's new third generation hardware and built a mesh networking capability so you can have sort of controls an entire swarm of RC bots over the course of a network.
Great, that sounds great. Can you talk a little bit more about the technology that is driving this?
Absolutely. So, originally, Particle's third generation hardware, and there's three different devices that fall under that category. Particle Audio, which is a Wi-Fi device, the Particle Brain, which is a cellular device, and then the Xenon, which is a new style of device that doesn't have Wi-Fi or cellular. It has a mesh audio radio inside of it. And all three of those devices can be used in standalone projects like you traditionally have used particle devices like the Photon or the Electron in the past. But they also come with a built-in new capability of being able to form local networks or mesh-based networks where the devices can actually work together. So you can have a series of devices, one gateway via Wi-Fi or cellular, and then a number of endpoint devices in Xenons that actually can read from sensors, control actuators, and then work with in concert with other devices on a network to send messages to the cloud via a gateway or to receive messages from the cloud as well, and either function with the cloud in concert as they do today or fully in sort of disconnected mode with only traffic on the mesh network doing its thing. Cool.
Brandon, I'm sorry to have you start over. In fact, we're going to need to start this whole show over because I understand we've been having a pretty severe audio issue here, and people haven't been able to really understand what we've been talking about. So, well, let's just start this one from the top. And again, thanks for your patience. Welcome to the first Make Live of 2019. It's March, sure. We missed the first 2 months. We got a little bit of a late start, but we're really excited to get going. If you're not familiar with the show, or with me, my name is Tyler Weingartner. I'm the video producer here at Make Magazine. And for a while, we've been doing this show where we have you guys join us live once a month, and we build projects straight out of the pages of Make Magazine. Only a little bit of a change this year. Oh, I'm sorry. We are still on Brandon, even though while I'm talking. A little bit of a change this year. They sort of get tired of me not being such a good project builder from time to time. Sometimes I'd do well, sometimes I'd really struggle. So they had a request for me to bring in some experts, and that's why I am joined today by Brandon from Particle. Brandon, if you don't mind saying hello.
Yeah. Hey, Tyler. Hey, everybody. Happy to be here, and thanks for having me on today.
Yes, glad to have you here. And since you're here, why don't you tell us what we're going to be building today?
Yeah, so we are going to build SwarmBots, or mesh networked RC SwarmBots. So just taking off-the-shelf $10, $20 RC cars that you can buy at a drugstore or toy store, and adding in a little power of mesh networking in those so that they can move together, sort of take commands through a central point within the network.
That sounds awesome. I can't wait to get started on this build. But before we do that, we really need to take a moment and talk about the folks who we work with here to make this show possible, and that's our good friends at DigiKey. If you don't know who DigiKey is, they are an electronics distributor based here in the U.S. They stock just about everything that you need for your next maker project, whether it's going to be boards like the particle boards that Brandon is going to be using in this project today, Raspberry Pis, Arduinos, even down to your base components like transistors, resistors, capacitors, and whether you need them in through-hole configuration or surface mount, they have it, they stock it really quickly, or they have it in stock, they ship out really quickly. They're awesome to work with. They make this series possible, and we want to thank them for joining us. And most importantly, everything you need to build this project, except I think the RC car, if I'm not correct, you can buy directly from them. You need to get the RC car on your own, and but once that's done, you'll be ready to get started building your own army of SwarmBots. And of course, if you have any questions for me, for Brandon, pop those into the chat below, and we will be sure to get those answered. But in the meantime, I'm going to kick it back over to Brandon, so we can get started building this thing. And all the while, I'm going to be hitting him with questions of my own. So yeah, awesome. Give us those questions, and we will get those over. All right.
Great. So so Tyler, let me go ahead and just switch over to the desktop here so we can get started.
All right, so what's the first thing we're going to be doing here? It looks like this is the RC car that you're going to be modifying.
Yeah, so I have, I'm going to slide on over to my desk here. Let me make sure you can still hear me. You still hear me all right, Tyler?
Yeah, I can see that just fine.
Okay, all right, great. So we're going straight from the box. So I haven't really done any prep with the device in the box, and I apologize if I accidentally bumped the camera a second ago. But we're going to take this out of the box, and we're going to meshify this thing. I have a particle Xenon here that's already been claimed in my account that's configured. And you may be able to see in the corner of the screen, I do have an RC car on the floor there. I do have some cars that are already on the network, or already on a mesh network, ready to go, and we're going to join this one too. So first step is just to have that satisfying feeling of getting a new toy or something out of the box. So let's pull this thing out.
Yeah. And while you're doing that, there's 3 flavors of these new particle mesh boards that kind of determine which kind of connection it's going to use. You mentioned this is the Xenon, and I unfortunately can't remember which one is which. Is that the one that's Wi-Fi based?
No, this is the one. The Xenon is the mesh only device. Yeah, so Particle's 3rd generation hardware does come in 3 flavors. There's the Argon, which has built-in Wi-Fi.
Yeah.
The Boron, which is the built-in cellular board, and the Xenon, it's just sort of a different style of device. It doesn't have a Wi-Fi or cellular radio, but it has a mesh radio inside of it. All 3 of these devices actually have mesh capabilities baked in. You can use them standalone mode to build a standalone project like you could the Particle Photon or the Electron. But you can also use these to create local networks of devices that can speak to and work with one another. And the Xenon is sort of the mesh-only device of that army. So that's the one that can be used to sort of be your endpoint device to read from sensors and control actuators and all that good stuff.
And because I've never really worked with mesh networks, that's one of those things that I like to just kind of quietly nod and pretend that I have a really good understanding of what mesh networking is. So for folks like me who I think I have an understanding and really don't, or for the folks that are bold enough to say, no, I don't know what that is. What is mesh networking?
That's a great question. So I'll explain it sort of with the contrast of traditional Wi-Fi or cellular. A lot of existing solutions out there, connectivity solutions, IoT solutions, what have you, sort of operate on this concept of every device has a one-to-one connection to the cloud. Or every device has a Wi-Fi or a cellular radio inside it. The devices sort of work standalone. And if you look at the sort of traditional home as an example, if I have a Wi-Fi access point in my home, and then a bunch of devices that are on that home network, I have a local network, but if the Wi-Fi access point goes down, I also lose connectivity on the network itself, right? Because most of our Wi-Fi routers also function as DNS servers. You get IP addresses for devices from that same box. And so if your Wi-Fi router goes down, devices on the network can't communicate with one another. There's not really any concept of a local network without Wi-Fi being present. Mesh networking works a little bit different in the sense that there's not a single point of failure in the network in terms of the network's ability to understand its topology, to understand how devices are on the network, et cetera, and things like that. And so mesh networking gives you the ability to set up local networks that can be isolated from the open internet. They can communicate to the open internet through gateways, but devices tend to be much more peer-to-peer in nature. They can communicate with other devices on the network, which is a pretty powerful concept, I think.
That's fantastic. And what is the range between nodes in the mesh network?
So the range varies depending on the kind of antenna you have. And any of these boards, you can actually put pretty beefy antennas on them. So the range definitely varies. But you would be talking just with the default settings out of the box. You'd be talking 30 plus meters between devices. And then part of the idea with mesh is that you can actually increase the distance and range between devices by adding additional nodes to the network, right? So if you need to go beyond that 30 to 40 meters, you can add additional nodes or repeaters within the network to actually extend the range, extend the resiliency of the network.
All right, so you've got the top of the this car here.
Yeah. So the plastic top is pretty simple. There's just two screws on the bottom there. So this is actually this board that's in here. There's a little through hole I see on here that I never really quite was able to identify the part numbers or anything. I never found a data sheet on it, but the surface mount I see that's on the top here is actually part of a set of really commonly used TX RX chips for remote control devices. And so given that was sort of the key to unlocking how this whole beast here operates. And so the first step that I'm going to go through here is actually to take a hobby knife and cut some traces here. And the reason why I'm doing that is to actually make it to where the RC cars, one of the demos that I have is actually using the remote control itself to control all the cars on the network. But I only want my leader car to take signals from the remote control. And I'm cutting basically the transmission pins on the others so that it will only take its orders, as it were, from the devices on the network, if that makes sense, from actual messages that go through the mesh network. So I'm just going to cut that really quickly. And once I've done that, really the key to the next step here, in order to wiring up this Xenon to the network, is to solder in a common ground pin, or solder in a ground wire that'll be the common ground between the two devices, and then one pin for each one of these motors. The way that the motors work here in the car is that one pin controls left forward, one controls left back, one controls right forward and right back. And so it's just, I have a number of wires here that are ready to go. So we're going to do a little bit of soldering to actually get these into the point where I can include them or hook them up to the Xenon. So shall I proceed? Do you want me to go ahead and go with that?
Yeah, and if you don't mind, while you're soldering, I have a couple of questions from the chat. King wants to know, can somebody speak on how fractal antennas are used to amplify signal?
Oh boy, not me.
Okay, that's not me either.
I am not an RF or antenna person.
Okay. And the other question is, if they all are mesh and one of them is on Wi-Fi, can you communicate to all of them through the one that's on Wi-Fi?
Yes, that's a great question. You absolutely can. Assuming that the gateway device is connected to the cloud via Wi-Fi, you absolutely can communicate to it. Any of the endpoints on the device. So particle devices have always, a few of the common features of particle devices have always been the ability to call functions and inspect the state of variables on connected devices, and then also to do publish and subscribe between devices. That is actually still true. I'll try not to drop the soldering iron on my hand. That is still true, even with the Xenon device. So as long as the Xenon is connected to a gateway to the internet, I can still do everything that I could before to call functions and variables on this device and to do pub sub between devices. I can also continue to do over-the-air firmware updates between devices as long as that gateway is connected. In addition, one of the things that's kind of cool or special about mesh, we think, is that if that gateway goes down, if it loses its connection to the internet, the devices can actually still communicate on the local network. So you can still do mesh-based messaging between nodes on the network, even though you can't do messaging out to the cloud itself.
Yeah. And I think this is a question that I can answer from Marion Maker, asking, will there be something about swarm intelligence? And I'm going to say, I don't think so. I believe you need a much more sophisticated robot to be collecting data from its environment, sharing that information with other nodes, with other robots and other nodes on the network so that they can all cohesively learn about their environment together. And I think in this scheme, really all we're doing is basically multiplexing the signal from the RC transmitter to all the robots on the Swarm network. Is that correct?
Yeah, that's absolutely right. So yeah, I did a lot of work on this over the last several months. Actually, I do live streaming on Twitch, and I worked on this a bit on my live streams in early January, February. And one of the things that I like to tell people as I was working on this was, these are not precision electronic devices. Like, these RC cars are not high precision devices. They are, the cheapest boards that could be made the day that they were manufactured. And so it's really more about sort of proving how easy it is to hack these cheap toys to get the concept of swarming, to create coordination between devices. But in terms of intelligence, in terms of like high precision coordination, all that, yeah, that's definitely not here within the project at this point.
Yeah. And if I can understand kind of the signal topology here, for the lead one, that you're still leaving the RC receiver intact and having to control the motors on it, is it also sending that signal over the mesh network, or is the particle mesh board that's in that car getting the signal from the control board and then sending that out to the other boards on the mesh network?
Yeah, that's a great question. So what's actually happening is the leader car is a Xenon, just like the other follower cars. It's actually not a gateway in the typical particle sense. There is an Argon that sort of runs the controller, sort of the gateway role within the network. But all of these devices are actually endpoint devices. The only difference between them is the firmware that they're running. And so the way that the leader car works, it has a couple of different capabilities or demos. In RC mode, what it does is it does an analog read on these 4 pins that represent writing an analog voltage to each of those motor pins, and then it just takes those and it sends a mesh publish message, which is a UDP based message on the network. It sends that to all the other cars in the swarm. And so really whatever you're doing on the remote control, it reads that, it sees a value between 0 and 255, and then it sends that 0 to 255 value over the mesh network. The devices receive that publish, and then they in turn just set that same voltage on the corresponding wheels.
Okay.
The other capability is more of a CAN sort of demo mode. So without the RC, without using the remote control, there are a couple of demos that are in the firmware. And all this firmware is actually, the GitHub project for this is available on the Particle GitHub repo. I can post a link to in a little bit. But that actually, there's also some demos that will do things like just follow the leader, move forward, move back, spin, do orbit demos, things like that. There's a number of demos in there as well that have been that you can just sort of run in pre-canned fashion. You trigger them using functions, and then they just sort of go off and do their own thing.
And we had a really important question from the chat. What is your Twitch account, Brandon?
So my Twitch account, I'll go ahead and I can type it in chat.
Okay.
Real quick, because I do have the chat open, but it's if I can spell it right the first time. So twitch.tv/Brandon Satrum, all one word.
Cool.
I typically will. I stream twice a week on Mondays and Thursdays, and the stuff that I stream is more of this kind of stuff. I do a lot of failing in public, as it were, building, trying to do IoT builds that don't work the first time, that need some additional work and love. And I do full stack stuff too. So we do firmware, hardware, but also building web and mobile and cloud applications that work with connected devices. That's part of the fun.
Yeah, that's failing in public is the fun experience of doing live builds like this.
Oh yeah.
That was I would always try and every time I would do a stream like this when I was doing them myself last year, I would always go with the intention of, I wanted to come out every time with a success, and I would get so much stress along the way, especially leading up into the stream. But it turns out as soon as I hit the big red, go live button, it actually calmed down a little bit, because I figured everything after that point is entertainment for the stream. And most of the time, I got a working build at the end. A couple times missed, maybe needed to do a follow-up, a little bit of follow-up to say oh, here's where I went wrong. Here's where I should have paid a little bit more attention to the data sheet.
I do a lot of that. I will typically start my streams with a recap of what we did last time, and then if I had anything still hanging out there, like I ran out of time or something wasn't working. I've had this happen a lot of times where something's not working, and then within 30 minutes of getting off stream, I figure out what it was. All of a sudden it's just me in my office again, and now it's working.
Yeah.
I'll go through recapping those and just letting everybody know sort of how we got it fixed. But that's part of the fun, to follow up and sort of share what I learned and what went right, what went wrong, that kind of stuff.
Yeah. Although some of the most fun things are that when you can attract a good group of people who work on projects like you do, sometimes the suggestions they have in the chat is just what you need to, similar to walking away from the stream for a little bit, just to clear your head. Sometimes look into the chat and see what suggestions people have. Sometimes it's the wrong suggestion, sometimes it's the right one.
And I've had some really good ones. There's a great, good number of folks that have come in and started sort of joining the streams on a regular basis and have been a great source of support. A few of them actually I saw popped in the chat here, like my friend Siva. There's several folks that have been a huge help for me as I completely forget what I knew 5 minutes before, or as I need some help, just sort of remembering how to get unblocked or work around problems. So yeah, that's where live streaming is a lot of fun. It's almost sort of like having that rubber duck moment in the code review where somebody will come and give you the sanity check and say, no, you totally misspelled this thing, or you forgot this thing, or don't plug that in because you're going to short something and burn yourself.
Yeah, you just you soldered that to pin 6 when it should have been to pin 7.
Yeah, exactly. Yeah, that sanity check. So I soldered on these 4 wires plus the ground. Now, an important thing here is just to have a shared ground between the two. And then the other 4 wires represent, on the other side of the IC, the motors that drive the various wheels forward, back, left, and right. And so you can see it here. I've actually got it wired up now. And got to put it in a battery pack. So that's another important piece.
Need that. We have a couple more questions from the chat. Bill O'Connor is asking, can you explain how the motors are driven? You mentioned that it was the signal was sent analog and not pulse width modulation.
Yeah, so I mentioned a little bit earlier that there's an IC on these cheap RC cars that I wasn't able to identify, but I think it's effectively an H-bridge that is just taking what you have. You've got basically 4.5 volts coming from the AA batteries, And let me actually make sure I plug in these batteries correctly while I'm talking. And so what that's doing, what I believe that IC is doing is just pulling power to do two things. One is to light up a little, there's a couple of little red LEDs at the top here on the car. So when I turn this on, it's just powering those LEDs and then just taking RC signals and converting those into, effectively just analog voltages that are being set on the other end.
And you mentioned that the voltage coming from that battery pack is 4.5 volt, or sort of 5 volt circuit there. Is the core voltage coming off of the GPIO pins on the particle board there? Is that 3.3 or 5 volts?
So it's 3.3 on the particle device, and so I'm using I'm gonna use a LiPo for that.
Okay.
So I do. You can power. There would be an approach to do this where you could power them the same. But to save myself from having to do the voltage regulator step in this whole thing, I'm just powering the individual RC cars separately using a LiPo, and then just pulling the power from the battery pack for the motors themselves.
Okay. And it's okay that the logic level coming off the particle is 3.3, that the RC board accepts the signal all the same?
Yeah, it hasn't been an issue for me.
Okay. And then we have one more question from Scott Pickett. Are the RC cars going to be compacted into a group at first or spread out? He's confused as how you can hone in on one specified position.
That's a great question. So they're compacted together. So one thing that this demo is not doing, that's a great question. There isn't any positioning taking place here, right? Like I'm not actually doing triangulation of these devices or detecting where they are. There's some add-on demos I've thought about, like adding an ultrasonic distance sensor to the leader car to do a little bit of a collision detection. But in terms of where the cars are themselves, none of the cars really know where the others are. The demo sort of assumes that I'm putting them in place at the beginning, and then they're just sort of running from that point.
Cool. All right, so I'm noticing it looks like you have the particle board powered up. The car looks powered up. What's our next step?
Yeah, so the next step is we can go ahead and run it. I'm curious if you think, Tyler, if I should actually run over, share my screen really quick and actually take a look at the code.
Yeah, let's do that.
Okay, cool. Like I mentioned, the car is already, so let me actually jump in and, where's the share my screen option here? Oh, there we go. It's the present now. Okay. So I'm going to do that and let me know when you can see my screen.
We can see your screen.
Okay, perfect. So there's two pieces to this, and like I mentioned, this is actually in the GitHub repo for this is available at GitHub Particle IoT/RC Mesh, I believe. I'm gonna forget what oh, that wasn't it. I'll find it. But the 404, I will find it and I'll post it a little bit later. But there's two pieces that actually happen here, and there's a few different demos in the repo. There's actually 4 different projects that are in here for the mesh controller, mesh vehicle. But the ones that are relevant to what I built today and I'm working on now is the mesh swarm leader and swarm follower. And the swarm leader is the brains behind the whole thing effectively. I'm mapping my wheel pin mappings for, like I mentioned, left, reverse, left, forward, right, forward, and reverse.
Yeah, actually,
and then
Brandon, before you go too much further into this, can you either full screen one of these or maybe make your font size a little bit bigger?
Oh yeah, I can do both actually. How's that?
Just make sure that it's easy enough for folks that watching the stream to see.
Yeah, absolutely. Is that a little bit better?
A little bit. For some reason, I don't know.
That too.
I'm guessing you have an extra wide monitor over there.
I do. Yeah. So
okay, yeah, because that's why your image is coming in, and it's not really using the full size of my screen. But this should be fine for for what we've got.
All right. Yeah, I bumped up a little bit more as well.
Yeah.
So I have, there's basically, like I mentioned earlier, there's two modes here. There's one that runs in RC mode. This is reading, taking the voltages from the pins on the remote controller itself, and then passing those along. And the other is demo mode, which like I mentioned, just runs some can demos. And the real meat here is a couple of particle functions. Like I mentioned, you can actually call, and this is running on one of the endpoint Xenons. So to the question earlier about can you call to these devices even if they're not publicly on or they're not on, don't have a Wi-Fi or cellular radio, I'm exposing functions here that switch the mode, that run a demo, or that will stop the demos. And this is on that endpoint device. And then when we're in the loop, it's basically just doing a couple of different things. If I'm in RC mode, what I'm doing is basically just checking my left, reverse, forward, my left and right pins.
Mm-hmm.
And then if I am getting a value on one of those pins, then sending that along. And so I'll show that. I'll show what that looks like. So check pin just does where is it here? Analog read on the pin, right? Again, then divides by 16 to give me a value between 0 and 255. And then it will, if the value is a positive value and has changed, then it's doing a mesh publish. And a mesh publish is like I mentioned, is a UDP broadcast message to every device on the network that's listening specifically for a topic. In this case, it could be left R, left back, left forward, left back, etc. And then it publishes that, and then also writes out a serial message as well. And that's it. Otherwise, it actually will send a publish event to turn the motor off, right? So whatever value it's getting, whether it's 0 or whether it's something greater than 0, it passes those values along. So that's how the RC mode piece basically works. And then the rest of what's in here is analog writes and messages that handle things like spinning left and right for the pre-canned demo stuff. So if I'm doing something like a turning right 135 degrees, so these sort of primitives that I've coded in here will do a mesh publish to tell the cars listening to take an action, and then we'll do the same thing on the leader car itself, right? And then delay based on what's actually pasted in there.
Yeah.
That's the leader. The leader is the meat of everything else. The followers have the same pin mappings, but all they're doing basically is just subscribing to these messages on the mesh network to either go left, forward, reverse, right, forward, reverse, or to turn all their motors off. And that's it. When it receives those messages, it just calls one of these pins and then just does an analog write to those individual pins. So this is much less complex. The swarm followers are, like you would see in a more real world kind of swarm, are just dumb devices that are listening for commands from a leader on the network itself.
And what's the sort of motor configuration of this car? Is it the normal RC configuration where you have a big drive motor that you can drive forwards and backwards, and then like a servo that you can use to change the steering angle of the front wheels?
I wish that it had been that way. That was actually what I went into this assuming was that I was going to have motors that were kind of discrete towards a wheel and direction. And there are some RC cars that are like that. One caveat I'll say is if you do this yourself and you go and buy one of these Thunder Tumblers, they can change. They can change over the span of 6 months. There are people who have been doing Thunder Tumbler hacking for years, and the devices have changed a lot over that time. And it tends to be sort of the cheapest boards, cheapest ICs that you can get at any given time. And so I assumed I was going to get 4 separate motors and then something like a servo to handle angling. But in fact, every motor is tied, or the motors are actually tied to a wheel and a direction. So the 4 pins that I've got will give me left and reverse, left and forward, right and reverse, right and forward. So in order to make both go at the same time, I have to do both. I got to basically pulse both left and right at the same time to go forward or back.
Okay, so it's a bit more like a tank control where you're driving. You have like a right motor forward back, left motor forward back.
Yeah, exactly. Yeah.
Okay. And also, Scott Piggott wants to know how many cars will there be in the swarm?
So right now, that's probably a good point to transition actually over to, let me switch my monitor here, or switch the camera here, because I have one on the floor as well. If y'all don't mind the rug.
Nope.
All right, so there are 3 cars on the floor now. The car in front that's been positioned in the front is the leader car, and then the other 2 are my followers. And so the car that we just added will now be the 4th car in the network. So let's go ahead. I'm going to go ahead and go put it on the floor, and then turn the other ones on.
I think Brandon's going to be a little bit hard to hear while he's stepping away from the microphone. But I think we're about to start seeing these SwarmBots in action.
All right, so I've got all 4 on. I have my remote control on here, and assuming that I soldered everything correctly, and assuming these batteries actually do what they're supposed to do, then we should start to get some action here. I'll mention, actually switch back over to myself just for a second, because it's worth sharing before I do this, as I delay the demo for just a second. This is the remote. It's just a very, very basic remote. Like I mentioned, it has the TX chip inside of it, runs off of a 9-volt battery. There's a button on the top that handles basically moving both cars forward at the same, or both wheels forward at the same time. Mm-hmm. And then these 2 handle left and right separately, basically. So that's how it works. So let me go back. Here's the moment of truth. All right, I'm going to turn around and look and see.
Okay, we've got 4 cars.
Yeah. Oh, 4th one took a second to get there.
A little bit out of sync now.
Yeah, very much out of sync. Yeah, I might have a pin problem on the last one. Give me a sec.
Okay. So the curse of the live stream, or the opportunity for some live troubleshooting.
That's right. I brought the 4th one back over to see if maybe I accidentally bridged, make sure I didn't bridge any pins while I was talking. Seems like it's all right. I was getting a little bit of something, just not very quick.
Okay.
Let me check on, let's see here.
And it looks like the one on the right in the swarm still has like a rapidly blinking LED that I was wondering if that's the indication that it's still trying to connect to the mesh network.
Yeah, it might be. So let me do something. There we go.
Two other questions from the Facebook chat. Shane Engel is asking, this works with most any car? Question?
Yeah, it should, honestly. If it's an RC car that you can hack and get access to the motors, then yeah, it should absolutely work.
Yeah, I mean, a little bit, actually like a year and a half ago, I worked with one of the authors behind the Donkey RC autonomous car. And that was a pretty popular and similarly affordable, actually I think more expensive than this one, RC car that we controlled entirely over a Raspberry Pi and like a motor control bridge. And then John Braden is asking, are they communicating with each other via Bluetooth? I guess he's maybe missed the introduction. They're actually communicating with each other over a mesh network established by Particle's 3rd generation microcontroller boards.
Yeah, and so the mesh radio that's inside of those, the devices all do have Bluetooth. But right now, it's not actually using Bluetooth mesh. It actually uses a form of mesh networking based on OpenThread. Which is the same thread networking stack that the Nest team uses for their devices, and a lot of other devices use those as well. The chip that's powering this on our actual particle devices is the Nordic NRF 52840. So Nordic Semiconductor makes a great SoC that provides the whole open thread stack and everything that we need to actually implement inside of the devices itself.
And then Jeff Jones wants to know, did we get this working before we decided to go live? I want to say you've probably had this working in the past. You have a new node that we've just added to this mesh network that
that was the challenge. So I got that the front three cars absolutely were working before we went live, and I tested them earlier today. It's the fourth car that I wanted to sort of just open from the box and see if we could actually get it going.
Yeah.
At that moment. And the reality too is, like I mentioned, these are not precision electronics, and so a lot of times, as I've done testing for this, the variances can be things like the AA batteries running the motor drivers, right? If I have a severely or close to drained set of batteries, then I'm going to get something different out of one of the cars than I may get out of the others. But I did change out a bunch of batteries earlier today, so that shouldn't be an issue.
Yeah.
Let me actually try this again. See if we can get them going forward.
All right, fingers crossed.
Yeah. So now
forward and back look like they're in good sync now.
Forward and back look like they're in sync. That last one out of sync a little bit. We got a little bit of a delay. It might be useful to actually run one of the demos, so that would be kind of an interesting. I can go back to sharing my screen.
Okay.
And talk through, instead of using I mentioned earlier, there's sort of the RC mode and then the demo mode. So let me do one of the pre-canned demos as well, so that we can see that doing its thing. So for this, I will share. I'll go back over to sharing my screen. And this time on the browser. So I mentioned, this is sort of the view within the particle console of my mesh network. And I'll go ahead and refresh this. I have my controller device, but then the actual 4 cars on the floor represent my individual mesh devices. And number 4 here was the final device that I added just now. Number 1 is my leader car, and it's actually what controls, like I mentioned earlier, running its various modes, right? So I can determine what mode that I'm running in right now by just calling one of these variables and finding out, okay, I know that I'm in, according to the source code, jump over there real quick. Mode 1 is RC mode. If I want to switch that over to demo mode, then I'll call switch mode with a different argument. And that will switch me, no. Should send me into, all right, hold on just a second. Oh wait, I think I need to actually do demo. So switch myself over to demo mode. So now at this point, I can actually give it a command for one of these demos to run.
Right.
I'm going to run the demo, the follow demo here, and I won't execute that until I move the cars back in position. So let me do that real quick. All right, so I'm getting happy breathing cyan from all the devices. So let me switch back to that camera. We'll run this demo real quick and triple cross the fingers. Back to the floor. All right. So now I'm back in the particle console, and I'm going to call that run the follow demo and hope for the best. Yeah. All right, so 3 of the 4. That was at least a little bit better.
Yeah.
than the RC demo. So I did definitely bridge a pin. So maybe it's time to debug, get back into debug there. And we can just plan to rerun that demo here in a sec.
And less of a question, but S Glitches is saying that those will not drive straight forward. This person played a lot with this particular toy with the nephews. Notice that if you drive them in reverse, the handling will be a lot better.
You know what? That's a great comment, and I have noticed that as well. Like I said, they're finicky little inexpensive toys. And I did notice that reverse tended to be a little bit of an easier way to get a reliable connection or a reliable performance from the.
Yeah, it'll be. I'm eager to get my hands on one of these when I have a little bit more time to start hacking around with stuff. Because one of my initial ideas is I want to see how well these will work on the Let's Robot platform. I think that'd be a fun platform for that.
Oh yeah, for sure. That's awesome. I'm sanity checking myself to make sure I even soldered the pins into the right places. Because that would be just like me.
Nothing more humbling than soldering from memory.
Yeah.
So you think you know it like the back of your hand.
Exactly, but no, not so. All right, I have one in here that might.
And if you solder from memory, but you have a reference handy, you'll probably be all right. But the second you don't,
that's right.
That's when it gets you.
All right, let me double check my pins.
And once again, if you have any questions about this project for Brandon, go ahead and pop those into the chat. And also, go ahead and look into the links up at the top, because all of the instructions on how to build your own SwarmBot just like this are right there in the chat. I'm going to go up and find it and post it again.
All right, Tyler. I had my. I see my problem.
What's your problem?
I soldered these wires to the wrong side of the IC. So I'm going to fix that real quick, but that should actually get us unblocked here. As we were talking and I was answering questions, I'm like, all right, I need to make sure I solder these in the right place while I'm answering questions. As I then proceeded to solder them into the wrong place. So there
it happens.
It does happen. It's more fun when it happens live.
Yeah. And then you get to troubleshoot stuff.
Let me turn that off. Okay. I always tell my kids, disconnect power whenever you do anything, and then here I don't.
It's generally good practice.
Yeah. Good idea. This should be quick.
Yeah.
This, and then we should be back to the races. So the question earlier about can you use any robot for this? My kids actually have a few of those, like I think they call them like tumblebees, but they look like little bumblebee RC cars. They run on like 2.54 gigahertz controllers, and they cost a little bit more than these. But they, I've been itching for them to get bored with those so that I can hack them and actually see if I can add those, because that would be one of my next steps, is sort of like do a homogeneous, or excuse me, a heterogeneous swarm network where I actually have a combination of Thunder Tumblers and other sorts of devices actually all working together. It'd be kind of fun.
So did you end up soldering something like reverse pins, or did you bridge something?
Yeah, no, I didn't bridge anything. So what I ended up doing was I soldered these 4 wires to the wrong side of the IC.
Oh.
These 2 rows here are actually the H-bridge IC, and I soldered them into the output side of the H-bridge, not the input side where the TX and RX stuff comes from. or where the actual commands are supposed to be input into the pin or into the IC itself. So I was just fixing that, just moving them to the right place.
I'm actually genuinely surprised that it was able to move at all.
Yeah, I need to look into that. I'm surprised by that too. The fact that it was doing anything is interesting. All right, so I'm gonna move this back down to the floor.
And then Gotcha55 asks, can you do a gear reduction to improve handling, or is the motor directly connected to the wheels?
I have not cracked open the back where the actual motor housings are, but based on what I have, that's a good idea, because I do have one of these that I totally ruined the PCB. I probably should crack open to see how that works, but I do believe that the pins are connected directly to the motors, so there's not any way to really fine tune beyond just setting analog voltages accordingly.
Yeah, I mean, it doesn't look like there's, I mean, unless the motor is internally geared.
Yeah. And all right, so let me switch back to the floor. We have the cars in position. Let's try to do this one more time and see if they all go together. Hey!
Yes, that's how they should be.
Now they're doing what they should be doing, at least a little bit more directly. So yeah. Yeah, so a little bit of live debugging. Hey, at least we figured out what it was.
It's not a make live stream without a little bit of live debugging.
That's right.
So welcome. We had another key question from the chat. Andy Perlick wants to know where you can get a blue soldering mat like that.
Oh, I love this mat, and it's magnetic as well. I got it on Amazon.
Okay.
I don't remember this. I don't remember the exact one, but it was it was under $20. Doesn't cost a lot.
I'm wondering if you can also find that on DigiKey. Do you remember? You don't remember what it's called, do you?
Oh, let me look. Let me look at it right now, because it is. Doesn't have a name on it.
Let's see.
I don't remember what it's called.
I think I found the one, but let me see what DigiKey has for it.
I can look at my order history. Why don't I do that? Because then I can definitely give you the name for it. XOOL, no, that's not the one. It's a KAISI heat insulation silicone repair mat. The S-160.
Yeah. Cool. Trying to see if DigiKey offers something similar.
Great. While you do that, I promised I would share the link to the GitHub repo, so I will do that here. Found the correct one.
I'm going to say maybe it looks like they don't have one of those, so we should ask them to try and start stocking this one. So people.
That's an essential part. Essential part of the workbench.
Yeah, I know that. I mean, that one looks a little bit better suited for soldering. Rockler, the woodworking company, they make a very similar one intended for like glue ups and things like that. The silicone mat is great because you can do any kind of glue up you want on it. Just let the glue dry completely, and once it's completely dry, you just roll the mat up and just peel the glue off, and
that's awesome.
No mess on your work surface. It's awesome.
Yeah, I like that. Yeah.
All right, and so now we know where to get a mat like that. It's a popular online reseller that unfortunately isn't DigiKey, and well, excellent. Like, is there really much else for us to do here?
I feel pretty good about getting it to that point. We got it soldered up out of the box, part of the network, with one mistake completely and totally on my part. We were able to recover from it quickly. So yeah, I mean, like I said, it is more a, the motivation for the project was to do a couple of things. One was to show how easy it is to take these sorts of hobby electronics these toys, and hack them with our own microcontrollers, whatever the brand may be. And then the other piece was to play with low latency mesh-based messaging. That's a new thing for us, adding this ability to do local UDP-based messages between devices. And I've done a lot over the last several months to play with this idea of how quickly you could send these broadcast messages, and is it fast enough that you could create some semblance of coordination. I did a similar thing last year late last year with Christmas lights, like NeoPixel strips, sort of all running together at the same time. The NeoPixels that are actually on the pegboard behind me are doing the same thing. Sort of when one strip gets to the end, it sends them. I don't know if you can see it with the light in my office, but if you one strip gets to the end, it sends a mesh published message basically to the next strip is listening for, and they sort of go on around the rectangle over and over again. So
yeah, unfortunately with the bright background, you can't really see it very well. But if you look really carefully at the bottom edge, or if I turn my overhead light off, it may make it. It's a very sunny part of the day. Yeah. Even before, if you look really closely at the kind of shadowed edge, you could see the line crawling across there. The shadow disappears for a moment. Yeah. So you can see there's NeoPixel lighting going on there, but
not the full on demo. Yeah.
No.
Yeah. But yeah, so that's to me an exciting part of this technology, and one that we look forward to. I'll continue to play with, and we can't wait to see what other people do with mesh-based networking as well. There's some cool stuff out there. There's a guy in the community that's actually built a mesh network to control, to sort of handle watering, I think 7 or 8 different house plants throughout his house, to sort of making sure that all of the individual plants are reporting their status through the central gateway plant, but that you can get cheaper devices actually in your plants instead of paying for Wi-Fi based devices in every single one of those. So some cool stuff out there.
Yeah. It's one of those things. I've been really excited by this product from Particle for a while now. The problem I've had is I just don't know. I haven't had a good project for it. I've had a couple of ideas for like point-to-point controls of like, taking input from a rotary encoder on one board to then like drive a motor on another in a remote location. So you get like wireless motor control, and hopefully something fairly precise using a rotary encoder on one side and a stepper on the other.
Yeah, very cool. Yeah.
But beyond that, it seems like, there's a lot of really cool examples on the Particle side of like how you could use this as a crop watering and monitoring system, or anything that kind of takes place over a really large landscape, which is something not many people have access to here in the San Francisco Bay Area.
All right.
I think my entire house would probably be covered by like 2 mesh nodes.
Right.
But there's a lot of fun applications for this, and this is definitely one that I wouldn't have thought of, and it's really cool to see it. So like, what is next for you with this project and these cars?
So if you check out the GitHub repo, there's definitely in there a bit of a wish list of things that I want to do next. I want to add some collision detection in there with an ultrasonic distance sensor. Another thing that would be sort of interesting is some range testing, to actually have, to use, some built-in APIs and other APIs to be able to have the cars sort of automatically drive apart from one another until the signal strength gets to a certain point, and then bring another car into the mix to sort of see what sort of range you can get between devices. And then probably the most ambitious on my list, it would be kind of fun to do though, would actually to take the RC, if you could actually get the remote piece working pretty reliably, that you could actually do sequence mapping with the remote, where it would actually log the basic, log the pin voltages over a period of 30 seconds, and then play that back on the other devices, to sort of create your pre-canned sequences using the remote instead of having to code those up. It'd be kind of fun.
Yeah. Can you get any data about the signal strength from any of the nodes on this mesh network, so you could do things like triangulation to determine the position of any of the robots on this network?
So we don't have full-on triangulation support yet, but you can get signal strength between nodes on the network. So you can definitely get the concept of signal strength between two individual nodes, and then we'll be adding more features around that, relatively soon, to where you can get that. Triangulation is something that people have asked about, and I think is really interesting.
Yeah, I was thinking
cool
like if you had boards that are on the mesh network in fixed locations, like in a large space, and using those to determine the location of various robots on the mesh network, so they can know where they are in the space, rather than using something like Dead Reckoning, which with a car like this probably isn't very useful. Oh, wait, I think we lost your audio.
I said, no, I muted myself. Yeah, absolutely.
Cool. All right. Well, if we don't have anything else for you, I mean, obviously, go ahead and check out the Git repo for Brandon for this project. And beyond that, where else can people find out more about you?
So I am on. I shared a link to myself on Twitch earlier, and I saw there's a question that came across about sort of what hours in time zone. I'm in U.S. Central Time, and I usually stream on Mondays from noon to 2 Central, and then 2 to 4 Central on Thursdays. I do evening streams sometimes as well. They tend to be more of personal projects. Like last night, I was messing with trying to get one of the new Google Coral boards set up and configured last night on stream. So I just mess around with kind of whatever strikes my fancy at any given time. I'm on Twitter as well. That same handle, Brandon Satrom, all one word, all lowercase. Those are the best places to find me. And also the Particle blog, blog.particle.io. I'm usually posting projects there every couple of weeks.
All right. And we have a couple more questions from the chat before we say goodbye. Non-Sanity wonders what options there would be to correct for variation in motor response, possibly an optical angle detection, or other members of the swarm to determine position and orientation.
I like that suggestion. So one thing, like I mentioned, I know there's a question earlier about sort of what the swarm knows about its other members. And frankly, there's nothing in there now. I like the idea of being able to do something like an optical sensor, an ultrasonic distance sensor, something to be able to get some sense of where other nodes are positioned. The range testing piece is interesting, like being able to use signal strength, but that's obviously not very fine grained. But yeah, definitely would interested in doing more of that kind of stuff.
Yeah, and for us, once again, my name is Tyler Wenger. I'm the video producer here at Make Magazine. I really want to thank you for joining us on the first Make Live for this year. I hope you enjoyed the changed format. And of course, we definitely want to thank our friends at DigiKey for making this series possible, and for providing a place where you can get all the electronic components that you need to build this project, the particle mesh boards, the wire, the solder, the breadboards, the batteries, anything else you need, everything but the Thunder Tumbler itself, you can get from them. They have it in stock, they ship really quickly, and they're wonderful partners to work with. Of course, otherwise from here at Make, if you're here in the Bay Area, make sure to get your tickets for Bay Area Maker Fair. That's going to be happening in May, and if you haven't been there before, you need to go. It's one of the most incredible maker events anywhere in the world. It's an amazing place to find people working on projects like this, or people working on huge projects like art cars, or craft projects, or anything in between, robotics, art. It's an awesome celebration, and you don't want to miss it if you're here in the area or have the ability to get over here. And of course, you can also read about this project, the particle SwarmBots, in the latest issue of Make Magazine. That's volume 68. So check that out. The article's written by Brandon here. And with nothing else here, I want to say goodbye to you. Thank you for your patience before we got this chat started, and be sure to check in with us next time here on Make Live. Thank you, Brandon, for joining us.
Thanks, Tyler, and thanks everybody so much. I definitely enjoyed it, and look forward to seeing what you all build in the future as well.
Me too. All right. Thank you all so much for watching, and we'll see you next time.
Hello? Hello? Hello?
What do you want?
I just need a TI launchpad.
Can't you see I'm busy here?
Don't be held hostage by the board order. Go to digikey.com to find thousands of boards in stock, all ready for immediate shipment.